All right, here we are looking at the last page of the 4.1 and 4.2 notes where you've tried these exercises. Hopefully you've got them done and are checking your answers, or maybe you're stuck and you need help. So let's look at exercise 1 here. We've got the weight in pounds of an astronaut who is r,000 miles from the center of the Earth is given by this function here. And the first question is this function a power function? In other words, can it be written as W of r equals k times r to the power p? And yes, you can. It is written like that with k equals 2,880, p is -2, so that's a power function. All right, now how much does the astronaut weigh at the Earth's surface, which is 4,000 miles from the center? Now r is the number of thousands of miles, so 4,000 miles leads to r equals 4,000 miles. So what we want to do is plug in r equals 4 to get the weight. So that would be 2,880 times 4 to the power -2, which is the same thing as 2,880 divided by 4 squared. That's what that negative exponent there means. And that's 2,880 divided by 16. Which is 180. And this is 180 what? What are the units of this? Dollars or kilograms or what? Well, it says the weight in pounds of an astronaut. So this should be 180 pounds at the surface. All right, how much does the astronaut weigh 1,000 miles above the surface of the Earth? So 1,000 miles above the surface means 5,000 miles from the center. So that leads to r equals 5. So we're going to find W of 5 for this part. And that's going to be uh, 115.2. So yeah, way up in the air. He's getting lighter, 115.2 pounds. And you might be saying, wait, that 1,000 miles above the Earth is in space, and I think you're right. Aren't people weightless in space? And the answer is no, they're not really weightless. They are still being pulled down by Earth's gravity. Let's say this is the Earth here, and 1,000 miles above the surface. The astronaut's probably like right here. But when you're at that point, they're not just sitting still. They're in a spaceship which is orbiting around the Earth, probably going thousands and thousands of miles per hour. I want to say it's on the order of like 30,000 or 50,000 miles per hour is how fast a space station, for example, orbits. Here's the spaceship. So if you're going that much sideways, he's still falling. There's still that much weight pulling him down a little bit, but he's going so far sideways that, because he's going around, that he ends up at the same height. So it doesn't feel like he's falling, although he is. He's just going sideways, which ends up taking you away from the Earth a little bit, so fast that he maintains the same height. So, yeah, nobody's really weightless in space, but you might not actually be getting closer to Earth, even if you're falling towards Earth, is the moral of the story there. Okay, so exercise 2. On your calculator or Desmos.com, let's make graphs of these two functions and then use them to answer these questions. So what values of x make x to the 1/2 less than x to the 1/4, and what values of x make x to the 1/4 less than x to the 1/2? So I'm going to head over to Desmos.com here. We're going to graph y equals, let me scooch the frame over so you can see that. Yeah, y equals x to the power 1/2, and also y equals x to the power 1/4. And I was zoomed way out looking in the millions before. I've got to zoom way back in. Wow, I zoomed pretty far out before. My computer's a little stuck. Okay, here we go. Okay, now we're only looking in the millions on the y-axis. All right, here come the thousands. I want to look at pretty small numbers to see what's going on with these. Okay, so here we got a kind of a more normal graph with these. And so on this graph, you can see the blue one is y equals x to the 1/2. So the blue one is y equals x to the 1/2 there, and the purple one is y equals x to the 1/4. Okay, so, and for both of these, you notice that there's no y coordinates if you plug in a negative value of x, because remember 1/2 means a square root, and you're not allowed to take square roots of a negative number. Same thing with fourth roots. So I'm going to paste this here so I can draw on it. So what values of x make x to the 1/2? That's the one that's in blue here. Less than x to the 1/4. Well, the y coordinates are less than this. So like, for example, we want to see where are, remember the x to the 1/2 means the y coordinates of this. This is like saying y is less than y. So the y coordinates are less over here. Like at these values of x. That's at x equals 1 where they intersect. So if x is between 0 and 1, you can see the blue one has smaller y coordinates. So the answer to this question is what values of x are those? It's x between 0 and 1. And what values of x make x to the 1/4 less? Well, once you get past x equals 1, like over here, suddenly the y coordinates from the purple one are lesser. So the values of x, where that works, is x is greater than 1. All right, so that's how you can solve that using that graph, is just look to see what values of x make these y coordinates, the purple y coordinates, less than the blue y coordinates. Okay, so for exercise 3, which power function dominates in the long run? So 1 over 5 times x to the fourth, or 1 over 4 times x to the power 5. So let's graph these. Oops. Okay, so in this case, remember, dominates means it is always larger for very large values of x. And in this case, at very large values of x, both of these are very small. Like when x is 6 or 8 or 10, both of these things get so close to 0 you can barely see anything. But if we zoom out a ways in the y-axis, a little stuck zooming. Can we zoom? Desmos is stuck. What we're going to do is we want to see, if I zoom out, I want to see which one of these, the blue one or the purple one, is above. Here we go. Okay, so all the way out here, it looks like the purple one is higher, but it's really hard to tell. So I'm going to zoom some more. Alright, and I zoomed while my computer stopped recording for a moment because it was a little stuck. And yeah, you can see that if I'm zooming out, this is like 1 times 10 to the negative 7, which is like 0.000001. It's like 1 millionth. And you can see here, the purple is clearly higher for larger values of x, out to like x equals 100. So yeah, we're going to say that based on this graph, the 1 over 5 x to the fourth dominates. That is the winner. All right. So that's 4.1, 4.2. Looking at the behavior of power functions, what happens when x is really big, what do their graphs look like and why, and how can you use them to model certain things, like the situation with the astronaut, or when you have things that are proportional to each other. I think you have some homework problems that are sort of similar to that. All right, so good luck with that homework, and I'll be posting the video for section 4.4 pretty soon.